Welcome to Study Loop.
All right, we're solving problem number 115 of Tro's chemistry structures, and this is problem number 115. And this problem that sample is composed of 7.36 grams of copper, but that's contaminated with an additional 0.51 grams of zinc. And we're told that measuring the atomic mass of the sample, should we? So we're supposed to find that atomic mass of the sample, which has been contaminated with some zinc. So the first thing you want to do is, since you're trying to find the atomic mass, you should look up what the molar masses or the atomic masses of these two respective elements are, copper and zinc. And from the periodic table, the atomic masses are 63.55 grams per mole for copper and 65.38 grams per mole for zinc. So what we do next is find the total mass of the sample, and then to find the respective percentages of these moles and multiply by the mole mass, the current mass of copper will be present. Do the same thing for zinc, and once we sum, that would be our apparent atomic mass for the sample. So the total mass of this sample, right, is essentially the sum of these two masses, 7.36 grams for copper plus 0.51 grams for zinc. That should be equal to 7.87 grams. So that's the total mass of our sample. These are the two different elements that are. So the apparent atomic mass of this sample is just like I said, taking the respective percentages of these elements, right, and then multiplying by their respective molar masses and summing that up. So the atomic mass of this sample is what's the mass of copper we have in this sample? We have 7.36, to ignore the units until the final. So 7.36 grams, and the total mass is 7.87. Right? So that's the ratio of copper we have present in this sample, right? And since it's copper, we then multiply by the molar mass of copper here, which is 63.55. So that should give us the atomic mass of copper present. Now we have to do the same thing for zinc, right? So for zinc, we have 0.51 grams. The total mass again for the sample is 7.87. Multiply this, so that's the ratio of zinc in our sample. Multiply this by the molar mass of zinc, which is 65.38. Obviously, the final results would be in grams per mole because the ratio is unitless here. So upon doing this arithmetic, you're going to see that the final result is 63.7 grams per mole, and that's taking into consideration the significant figures in the result.